Hello guys, this is part 2 of introduction of software engineering book. In this video we will start from system evolution. So this is the part of socio-technical systems as we were discussing. Previously we discussed system integration and subsystem development. And moving on, we will start discussing on system evolution. And in this chapter we will discuss system evolution, system decommissioning, and organization, people and computer systems. Organization process is also part of this video. Procurement process, development process, operational process. This is the part of chapter number 2, and we will discuss each and every aspect of this chapter in later videos when we will start comprehensively narrating the videos chapters one by one. Then legacy system. There is different positions of components like support software, system hardware, application software, application data, business policies and rules, business processes. And then there is business process, application software and support software, and combinedly make a socio-technical system, and one is more which is actually unreadable at this moment. However, we will include that figure when we will discuss this in detail. Then there is a number of questions which we will discuss again when covering this thing in details. Then there is a critical system, which is chapter number 3. In this chapter we will discuss a simple safety critical system dependability, availability and reliability, safety and security. So insulin pump structure, there is a example. First figure in the book, there is a power supply and an insulin reservoir, needle assembly, pump, controller, clock, alarm, sensor, display 1 and display 2 are the subsystem of the whole pump structure of insulin pump. A simple safety critical system, data flow model of insulin pump. There is a blood sugar sensor, blood parameter, blood sugar analysis, blood sugar level, insulin requirement computation, insulin requirement, insulin delivery controller, pump control commands, and insulin pump, and then there is the insulin. There is a system dependability, like availability, reliability, safety and security. All these components are major aspect of dependability. Moving on, there is a dependability cost dependability curve, like how much does one system have dependability, the more the cost it will be. Availability and reliability again is a huge concern of any process, software engineering process. There are system failure, system error, system fault, human error or mistake are the major part of this chapter. And then there is a system as input output mapping, software usage pattern, user 1, user 2, user 3, erroneous input. It is safety, and in safety there are the terms which we will use are accident, hazard, damage, hazard severity, hazard probability and risk. Whereas then it comes security, exposure, vulnerability, attack, threat and control. These are the components which we will discuss in chapter number 3 while discussing the security section. And then the chapter 3 is completed. There is a different number of exercise questions. We will discuss this as well. And here the software process comes. In this chapter we will discuss process of software process model, software iteration, process activities, the rational unified process, and computer aided software engineering. Software specification, software design and implementation, software validation, software evaluation are the major four part of software processes. What are the software process models? One is waterfall model, second is evolutionary development, third is computer based software engineering. So these are three major type of processes. One is software life cycle. So first of all, there is the requirement definition, system and software design, implementing and unit testing, integration and system testing, and then operation and maintenance. So discussing first the waterfall model, there is 5 major steps. First is requirement analysis and definition, system and software design, implementation and unit testing, integration and system testing, operation and maintenance normally. And then evolutionary development, outline description, concurrent activities, and there is final output. Like when we give an output description, there are 3 concurrent activities like specification, development and validation. And in specification there is a final version, there is version 1, version 2, and then from once the specification are finalized, then there is a development. And development and specification, there is a relationship between development, specification and initial version, and then development and intermediary versions, and there is again intermediary versions and development and validation, there is a relationship, and then there is a final version after validation. So this is very complicated, hence, but at the same time very important relationship between the different component of process of software engineering. Then there is evolutionary development. In evolutionary development, there is exploratory development and through a way prototyping. So this is where again we will discuss again the process is not viable and system is often purely structured. And there is component based software engineering. So here the requirement specification, component analysis, requirement modification, system design with reuse, development and integration, system validation. The reuse oriented approach lies on large base of reusable software component and some integrating framework for these components. So these are the detail of the component based software engineering process for software engineering. There is process iteration. So if we go back to the first part, the waterfall model, and we realize that the waterfall model are further divided into evolutionary development and evolutionary development, and then there is component based software engineering. There is a very good case study like for small and medium sized system up to 500,000 line of code. I think that revolutionary approach is best approach to development. The problem of revolutionary development because particular execute of large, complex and long life systems where different teams develop different parts of system. It is difficult to establish a stable system architecture using this approach, which make it hard to integrate contribution from the teams. And then there is process iteration. In process iteration there are first thing we will discuss incremental delivery, and spiral development. Yes, there is two support of iteration system, iteration process. So process iteration, there is increment delivery, where we have to define outline of our requirement, then assign requirement to increments, design system architecture, and then develop system increment, validate increment, integrate increment, and validate system. When if the process is final, our system's functionality is as desired to the outline of requirement, then we can stop this. Otherwise we have to go back to again step number develop system increment. And with that, the spiral development. In spiral development, there are objective setting, risk assessment and reduction, development and validation, and then planning. So as in figure 4.5, Boehm's spiral model of software process, which is covered by IEEE Conference 1988. So start from a requirement life cycle plan, and then review, and then is risk assessment and prototype 1, and then concept of operation, and then there is a risk process. There is similarity of tasks at each level. So you can see there is, if there is a prototype 1, there is a risk assessment. If there is a prototype 2, there is another risk analysis. If there is a prototype 3, there is another risk analysis. And if the operational prototype, there is also a risk analysis. At the same time, if you see, if there is a prototype 1, there is also a review. So we have to keep reviewing our prototype again and again. Whereas development plan is only comes at when we have designed our prototype 3. When operational prototype is designed, then we can do some integration and test our plan. At the same time, when we are in the prototype 1, there is a concept of operation, whereas in prototype 2, there is software requirement and requirement validation. In prototype 3, we have product design and design V&V. Whereas we are in a final stage when the operational prototype is designed, we have to look after the detailed design, code, unit test, integration test, acceptance test, and service. And after that, we can develop and verify next level product. Otherwise, evaluate alternatives, identify, resolve this. This is a ongoing process as we develop our prototypes. However, we will discuss the more case studies on this. There is process activities. The four basic process activities of specification, development, validation, and evolution are organized differently in different development process. One is software specification. Like, what is relationship between these subsystems, the requirement engineering process. One is feasibility study. After feasibility study, there is a feasibility report. After feasibility study, requirement and specification and analysis, and we put this in requirement specification and system models. Parallelly, these system give feedback to the requirement document and requirement specification, And then there is a relationship between requirement validation and requirement specification, and user and system requirement. And ultimately, requirement validation have relationship with requirement documentations. So all these are parallelly integrated. So there is a four major process activity of specification: development, validation, evolution. And then there is software design and implementation. Here you can see a general model of design and process. There is design activities and design products. And then we can see the debugging process: locate error, design error, repair error, retest program. And then software validation. Before hardware validation, there is a relationship between the component testing and system testing, and then acceptance testing, the overall testing process. And there is one another major figure: testing phases in software process. So this is a different relationship between subsystems. For example, there is service. It start from requirement and specification and end it with services. There is software evolution, system evolution, how system evolve over the time. The rational unified process. The phase iteration: inception, elaboration, construction, transition. So business modeling: requirements, analysis and design, implementation, testing, deployment, configuration and change management, project management, environment. These are the major workflow which we will discuss in our later videos. Then these are computer aided software engineering, which is called case. There are different tools type. For example, if there is a planning tool, then we have PERT tools, estimation tools, spreadsheets, identity tool, text editor, diagram editor, and word processor. Change management tool, requirement traceability tool, change control system, configuration system tools, version management system, system building tools, prototyping tools, very high level languages, user interface generator, method support tools, design editors, data dictionaries, code generators, language processing, compilers, interpreters, program analysis tool, code reference generators, static analysis, dynamic analyzers, testing tools, interactive debugging tools, documentation tools, page layout programs, image editor, reengineering tools, cross-reference system, program restructuring system. So here is again a figure: activity based classification of case tools. So there is four major processes: specification, design, implementation, and validation. And there is different tools like planning tools, editing tools. Whenever we are working on specification tools, we need to have planning tools, editing tools, documentation tools, change management tools, prototyping tools, method support tools. And we are on at the end of the stage: validation and verification. There are many tools which we need. For example, testing tools which we use second time after implementation. Here is a tool and workbench and environment. So what is case technologies all about? These are tools and environments. In tools we have editor, compiler and file com- computers, whereas environment or integrated environment or process centered requirement. So another piece of figure is analysis and design and testing, which comes under the programming section. So analysis and design further divided into multi-method work branches and single method work branches, whereas in testing there is a general purpose workbenches and language specific workbench. So guys, this is end of chapter number 4, and there is project management, which we will discuss in our next video. Thank you.